In this video, we're going to walk through the solution to an example problem that guides us through the calculations of 4 different types of ways of representing concentration. So this problem has a lot of information in it right off the bat. We have 0.35 grams of ammonium, and it has a molar mass of 17 grams per mole and a volume of 0.48 milliliters. It's dissolved in 200 grams of water, and it has a volume of 200 milliliters. And now we're going to calculate the concentration in a couple different ways. So right off the bat, the first thing I'm going to do is recognize what my solute is and what my solution is and what my solvent is. So I have less ammonia than I have water. So my solute is going to be the ammonium. The solvent will be the water. And the solution is both of them together. So let's start with percent mass by mass. This is going to be equal to the mass of the NH3, because it's my solute, divided by the mass of the solution, times 100. So the mass by ammonium is given as 0.35 grams, but the solution mass is not given to me. I'm going to have to do a little calculation. I know it's my water plus my ammonium, so it'll be that 200 grams of water plus the 0.35 grams from the ammonium times 100. So this will be equal to that 0.35 grams divided by 200.35 times 100, which is going to be equal to 0.175%. Pretty small. So now we're going to go ahead and do volume per volume, which will be very similar. Percent volume by volume will be equal to the volume of our NH3 divided by the volume of our NH3 plus our water, because we really want the volume of our solution to be on the bottom of our fraction, times 100. So we're told that we have 0.48 milliliters of our ammonium. So I'll put that on top, and I'll right away put it on the bottom, because I know I need to add it to my solvent, which is the 200 grams of water, which has a volume of 200 milliliters. So this is starting to look a lot like that mass-to-mass problem. It's a little bit different, though, because of the density of our solutions here. So it'll be 0.48 divided by 200, 0.48 times 100, rather than the 0.35 that we did before. And we get an answer that's 0.239%, which again is still very small, but it's almost twice as big as what we had before, or maybe 50% bigger. Now let's take a look at percent mass per volume, which is going to be equal to the mass of our ammonium, now divided by the volume of our ammonium plus the volume of our water. Oops. And we're going to make sure that our volume units for this are in, these need to be in milliliters, and my mass needs to be in grams. And luckily, we've been given grams and we've been given milliliters initially in our problem. And so I'll plug in the values that we have been given. So this is going to be equal to that 0.35 grams of ammonium divided by our 0.48 milliliters, which is the volume of that ammonium, plus our 200 milliliters of water, all times 100, which will be equal to 0.35 grams divided by 200.48 milliliters times 100. And then plugging this value into our calculator, we're going to get something that was very close to our mass to mass volume. It'll be 0.175% for our percent mass per volume.